Hello everyone, welcome back to Physics Physics. In this particular video, we are going to start our new topic, which is graphical analysis of motion. Basically, the motion can be easily analyzed by the graphs, right? So our first kind of motion is rest. Okay, so here basically we are going to plot three type of graphs, which are distance versus time, velocity versus time, or speed versus time, and third graph will be acceleration versus time. Okay, so our first graph is distance versus time, right? So here the object distance is not changing with the times, so this will be particularly at rest. Okay, our second kind of graph is like object is at rest, so velocity versus time graph. Okay, so velocity versus time graph is going to be velocity is being zero. So here velocity is zero. Okay, and also velocity is zero, velocity is not changing basically, so acceleration versus time graph will be here. Okay, so acceleration is zero, and so these are the three graphs which basically represents the motion, which is rest kind of motion. Okay, our second kind of motion is basically uniform motion. So here we are going to plot three type of graph: distance versus time, velocity or speed versus time. Third graph is acceleration versus time. Okay, so in the basic so basically in the uniform motion, distance changes uniformly with the time. Okay, so in this case the graph will be a straight line. Okay, if distance and displacement are basically changing linearly with the time. Okay, so here you can take distance is directly proportional to t. We differentiate distance with respect to time, then you will get velocity is directly proportional to t power 0. Okay, so here the velocity will be constant. So here velocity is constant. Okay, and in the third type of graph, acceleration is basically 0. Okay, here the acceleration will be 0. The reason being the velocity is constant, which is not changing with the time, so acceleration will be 0. Okay, so these are the three graphs for uniform motion, right? Okay, so our first kind of graph is distance or displacement versus time. Our second type of graph is velocity or speed versus time, and our third kind of graph is acceleration versus time. Okay, so uniformly accelerated motion. Okay, so here the distance is basically proportional to the square of the time. Okay, so here the graph is like this. Okay, so distance is directly proportional to t square, and if we differentiate the distance or displacement, then velocity will be directly proportional to t. In this case, the velocity time graph will be straight line. Okay, and third kind of graph is basically acceleration is directly proportional to t power 0. So here the acceleration will be constant. Okay, acceleration is constant. Okay, so these are the uniformly accelerated motion. In such kind of motion, acceleration is basically constant, like it is not changing with the time will vary, but acceleration will be constant. Okay, our third kind of graph is uniformly. Okay, so basically here the distance is, here basically acceleration, here basically velocity is increasing with the time. Okay, so our second kind of graph is uniformly retarded motion. So that in that case the graph will be like this, and velocity will decrease with the time. And third kind of motion, acceleration will be negative. So here acceleration is negative, here acceleration is positive. Okay. This is retarded motion, this is accelerated motion, this is retarded motion, this is accelerated motion, this is accelerated motion, this is retarded motion. Our next kind of motion is basically non-uniformly accelerated motion. Okay, in this kind of case, we are going to plot distance versus time graph. Here, basically, distance is directly proportional to t power n, where n is basically greater than 2. Okay, so in such kind of motion, the graph can be like this. Okay, so in such kind of cases, graph can be like this. Okay, so basically, here distance is directly proportional to t power 3, t power 4. So such kind of motion is basically known as non-uniformly accelerated motion. Okay. So that's all for the graphical representation of the motion. Stay connected to the channel for further videos. Thank you so much.